Please briefly summarize your industry education, professional background, and current role at AEIS.
I'm a mechanical engineer with the graduate level specialization in non-destructive testing and metallurgical failure analysis. And throughout my career, I have focused on testing, inspection, and certification of engineering materials and business systems, specifically quality management system implementation, welding metallurgy, and non-destructive testing. These are my passion. Currently, I head the organization here at AEIS, but my primary responsibility is that of a chief innovator.
How does AEIS fit within the infrastructure industry, and what does it do in terms of inspections? And please cite some recent examples.
Owners, they envision a project. Design teams will help put that vision on paper through drawings and specification. And then the construction teams build the project out. Now, we act as the independent eyes and ears for the project. Whether it's the owner, whether it's the design team, whether it's the design build team, ensuring that the construction is done as per the approved design documents. For example, before a specific space on an airport building is occupied, let's say the owner here in this area would be Port Authority of New York, New Jersey. They would require a certification letter from the engineer of record and the special inspection agency of record, which would be like AEIS. And a typical approach for many inspection agency can be, you perform the inspections, you cite deficiencies or non-conformances, and walk away, and it's actually the contractor's job to fix. However, our teams are hyper-focused on developing tracking systems, punch lists, logs, along with the construction team, so that the deficiencies are addressed in a timely manner and the sign-off process can go smoothly. Another example is on a recent bridge project, our highly attentive inspection teams, they identified some transverse cracking in the wells before the construction phase, during the construction phase. And they were able to get to the root cause of the issue due to meticulous capturing of the data in the earlier stages of the work.
How common are cracks and other damage on bridges and other infrastructure?
The cyclic loads induced as the traffic flows through a bridge and the stress rises inherent to the structure make the presence of cracks a very high possibility. I could say certainty, but that would be disputed, but definitely a very high possibility.
Okay, so what happens when flaws or issues are detected on a bridge or building, and how are problems resolved? Could you go through that?
So all construction is done as per established codes and standards. These are built into the contracts. The contractors are supposed to construct as per them. The design team is designing against them, and we as inspection agency, we inspect as per those. So these codes and standards, they provide detailed limits on acceptance of flaws and issues. And when no acceptance can be found, the design team provides the basis for acceptance. For example, for bridges, the Federal Highway Administration has developed a bridge inspection reference manual that details the fundamentals of bridge inspection. AASHTO is another organization which has developed a manual for bridge element inspection. Now, these programs are adopted by all the DOTs, modified to suit their state's requirements, and they usually commission, biennial bridge inspections. Like every 2 years, they would commission inspections. The extent of these flaws are identified by an inspection testing agency, and depending on the size and the propagation of these flaws from previous inspections, the flaws are repaired using pre-established, and qualified procedures. So, and all this work is done under the supervision of a structural engineer.
What are non-destructive testing and metallurgy testing practices, and how can they reduce the chance of future catastrophes?
I'll answer the metallurgical testing first, because for the most part, these tend to be destructive, and they're usually performed before the start of a project. And you'd wonder how a destructive test would prevent future catastrophe. What is done, I'll give you an example. There's a test called a procedure qualification test, which is carried out and it replicates the condition in which the actual work will be welded. So you take some test coupons and they are welded with the same welding process, electrode, current, voltage, speed, preheats, and all different kind of variables. The resultant heat inputs involved simulate very similar mechanical properties in the test coupon as the actual work. So then this test coupon is, tested for soundness, ductility, strength, toughness, and some other properties. If the resultant properties meet the project specification and the codes, then that same parameters can be taken for actual work, and you can expect to get a final product which meets the code requirements. Any test that does not affect the end use of a product is termed as an NDT method. The first and foremost is visual inspection. That's probably the first time somebody inspected an apple or a fruit and said, okay, this is good for consumption. It's a very powerful tool. The other two NDT methods that are very commonly used are radiography, X-ray, and ultrasonic testing. Most failures occur when there is a weakness in the material, usually due to the presence of something we call as a stress riser. So what are these stress risers? Cracks, lack of fusion, undercuts and welds, notches, all of these are stress risers, And currently, I'll give you an example. We are engaged in performing ultrasonic testing of welds on orthotopic decks for 3 major bridges in the area. It's a very effective technique in detecting planar flaws, such as lack of fusion, and other stress risers, which can lead to catastrophic failures. So our testing using qualified personnel can prevent such failures from happening.
What should our engineering audience be thinking of in terms of inspections and how to make their infrastructure safer? How should that affect their designs?
Design-wise, I think, a lot of this is covered by the programs that are in place, the AASHTO manuals, the Federal Highway Authority manuals. And I think one of the critical aspect here is when you engage personnel for inspections, you have to have people who are experienced in this work. And, typically these standards also stipulate, okay, a person should have such and such quote unquote certification, but you have to distinguish between certification and qualification. Not every certified inspector is qualified to perform the work. And you got to ensure that the inspection teams you're hiring, they have processes in place to approach your inspection and testing program. And they're not just another company supplying certified manpower. And I think that that's crucial to a very successful inspection program.
Is there anything they can do at the engineering level that can make inspection easier, as far as how they design and create things?
There are certain things that can be done. I'll give you an example. Most codes, let's say if you take, the structural welding code for buildings, the code has different criteria for checking or testing static structures work versus cyclically loaded structures, and that kind of makes sense, right? But when the drawings come, like 95% of the drawings that come out there do not differentiate what joints are statically loaded and which ones are cyclically loaded, and then it does not make sense to use the cyclic loaded criteria, which is much more stringent for statically loaded, structures or connections. And I think it would make a big difference in actually inspection protocols if these are clearly laid out in drawings.